Okay, so this is 7.2 stoichiometry calculations with moles, mass, gas, volume, and molecules. All right, so if the quantities are given or asked for and are not already in moles, then we need to make it into moles first, just like what you're doing in your chapter 5. So before crossing the mole bridge between two chemicals, units must be converted to moles. All right, so remember you have mass of something, volume of something, or molecules of something. Change the moles, right? You're dividing by the molar mass, or 22.4 or 6.02 times 10 to 23, and you go from moles given, right? um, to moles of your unknown, right? Your conversion factor, what you want should be on the top, what you have is on the bottom. So with this one, you can go mass of something to moles, moles of your given to moles of your unknown. Then you can go to volume or mass or molecules by multiplying by the molar mass, 22.4, 6.02 times 10 to 23. All right, so always have to change the moles first. All right, and then balance it according to your chemical reaction equation. All right, so for these multi-step conversions between different chemicals, it always helps to make a plan. So write down your plan, but at least have it in your head before you do it. All right, I find those who write down the plan, they make less mistakes overall because they've thought about it before they do it. All right, so for example, if the volume of a gas that reacts and asks about a certain product, so you go volume of X to moles of X to moles of Y to mass of Y. All right, so you're given the volume of gas and ask for the mass. That would be your plan, your general plan for that type of reaction. All right, so this tells me that it's a three-step process using conversions we've already used, but with a middle step that use the ratio of moles between the two species. All right, so be careful with these questions. Look for exactly what they're asked for. When you see a volume question, do not automatically assume 22.4 liters per moles. You only use this for a gas at standard temperature and pressure. So it should be gas. You should have a gas being produced or consumed in the reaction, and it should say STP. All right. Sometimes with volume, you're going to do concentration questions, and that's going to come into our next. We're going to talk about those in our next section. All right, so another flow chart. So your step one, write a balanced chemical equation. Always do this if you don't have a balanced equation. Make sure you have a balanced equation, right, for your reaction. Calculate the moles of your substance, moles of your known substance. Use the mole ratio to calculate the moles of your unknown substance, and then convert from moles to the specified quantity of whatever you want. All right, so change from whatever you have to moles, change from moles of your known to moles of your unknown, and then go from there to get what you want. All right, so different types of questions. I'll go over some, but there's lots of different types, and you'll get lots of practice in your assignment too. All right, so for example, this is mass question. So I start with mass of something and I go to mass of another. So how many moles of potassium chloride are produced if 25 grams of potassium chlorate decompose? All right, so we start with our potassium chlorate, that's our KClO3, going to potassium chloride and your oxygen. Make sure everything's balanced. So you have this reaction. All right, so make sure you balance the reaction, or at least make sure it's balanced. So I have my balanced reaction. Step two, I'm going to make a plan. So my plan, I want to go from my 25 grams of potassium chlorate to moles of potassium chlorate, and I'm looking for potassium chloride. So I'm going to go from moles of potassium chlorate to moles of potassium chloride, and then to mass of potassium chloride. All right, so there's my plan there, right? Mass to moles, moles to moles, moles to mass of your KCl. All right, so start with what I have, divide by the molar mass, then go moles of each, and then to grams. All right, so we go 25 grams of potassium chlorate, divide by the molar mass, times 2 divided by 2, times your 74.6 grams over 1 mole. All right, so make sure you're not skipping steps. All right, you can't combine anything. So if you miss a step, that's minus 0.5. All right, missteps, wrong units, wrong sig figs, minus 0.5. All right, so these ones would probably be out of 3 or 4 marks. All right, so don't just go right to the final answer because you won't get any of the marks. Show all your work. If you do a calculation, show the work. All right. Even if it's 2 over 2, all right? You need to show this. All right, you could also have volume questions. So we have this question: what volume of hydrogen is necessary to react with 5.00 liters of nitrogen to produce ammonia? Assume standard temperature and pressure. All right, so first things first, we write out our balanced reaction equation. Make sure left and right side is good. All right, so my plan, I want to go from volume of my nitrogen gas to moles of nitrogen gas, then to moles of H2, and then to volume of H2. All right, so there's my plan. Volume to moles, moles to moles, moles to volume. All right, so with this one, 5.0 liters. All right, divide by 24, get moles of N2. Moles of N2 cancel, we got moles of H2. H2 cancel, and then we're going to get liters of your H2, which is going to be 15.0 liters. All right, so 3 sig figs on this one. All right, so, or they could be any combination of mass, moles, volume, number of moles, or atoms. So this one, right, if a sample of propane, C3H8, is burned, what mass of water is produced if the reaction produces 50 liters of CO2 at STP? All right, so again, first things first, write out your balanced equation. Make sure everything's good. All right, oh, it looks like it's not balanced. All right, so we're going to need a 3 there. So I balance it carbon, hydrogen, and oxygen. So my hydrogen's next. I got 4 there. And then we got what? 4 and 6. That means we got 10, so 5 oxygen over here. Okay, so my plan, so sample is burned, what mass of H2O is produced? We're looking for a mass of H2O producing if it produces 50 liters of CO2. So we're going to start with our volume of CO2, go to volume of CO2 to moles of CO2, right? Then moles of CO2 to moles of H2O, then moles of H2O to mass of H2O. All right. So write down, so according to my plan, I'm going to write down my my work. So right, liters of CO2 to moles of CO2, moles of CO2 to moles of H2O, moles of H2O to grams of H2O. I got 3 sig figs all along. Remember these ones here, the 4/3. These are perfect numbers, right? So according to our conservation laws, we got 4/3. So 4 moles of H2O over 3 moles of CO2. So these are perfect numbers according to our laws of conservation. So no sig figs on that. So sig figs in the question gives us our sig figs in the answer. All right, let's do another one. So what volume of NH3 at standard temperature and pressure is produced if 25 grams of N2 is reacted with excess H2? So we're going to start with our grams of, start with writing down our formula equation, balancing it out. We've done this one before. So I'm going to go mass of N2, right, to moles of N2, and the moles of N2 to moles of NH3, and then moles of NH3 to volume of NH3. All right. That's my plan. All right, write down my work. Start with my N2, right? Divide by the molar mass times the molar ratio, the balanced molar ratio according to our reaction equation, and then multiply by our 22.4. All right, so grams of N2, moles of N2, moles of N2, moles of NH3, moles of NH3 to liters of NH3, and we got 3 sig figs in our final answer, 40.0 liters of your NH3. Okay, next one. How many molecules of water are produced if 2 grams of sodium sulfate are produced in the above reaction? All right, so we have this reaction looks like a neutralization reaction. Looks balanced. Nope, not balanced. We need 2 up there. All right, so now it looks balanced. We got 2 hydrogens, 2 hydroxides. That makes 2 waters. NAs are balanced. SO4s are balanced. All right, so we're good. So we have mass produced if 2.0 grams of sodium sulfate. So we have mass of sodium sulfate to moles of sodium sulfate, and moles of sodium sulfate to moles of water, and then to our molecules of water. That's what we're looking for. All right, there's my plan. Mass to moles, moles to moles, moles to molecules. So we have our sodium sulfate, Na2SO4. So the molar mass of that, 142.1. So grams divided by moles, moles to moles, and then times 6.02 times 10 to the power of 23. Formatting on that got messed up, but it should be the power of 23. And then, so we notice we got 2 sig figs in the question and 4 sig figs and 3 sig figs. So our final answer should have 2 sig figs. So it's 1.7 times 10 to the 22. All right. So your assignment 7.2 on page 127, 678. There's also mixed problem worksheets. Very, 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 very important topic. So make sure you get this down and do as much work as you need.